All right, guys, welcome. This is going over your topics 4 to 6 test that we just took. So let's take a look at some of these problems. On problem 1, they asked you if which equation does x vary directly with y? And what that means in just the easiest terms is which equation shows a constant line, so a linear function, which all of these are linear, but they want it to go through the origin, okay? So they want something that looks like this as opposed to something that looks like this, okay? Essentially, there's no y-intercept, and the only equation that has no y-intercept would be this one right here. The y-intercept is 0. So let's take a look at number 2. With number 2 here, it says we have a table that has total distance. So it's starting at 0 and goes up to a total of 3 seconds, and the person ran a total of 30 meters. So they want to know, what is the average speed between points A and B? So with this, guys, what that means, the second they say between points A and B, that means that we can ignore all of this up here, and we're going to ignore this in between part. We just want to know this. Okay, so the first question they ask is, what is the distance traveled between points A and B? So I look from 12 meters to 30 meters, and that is a difference of 18 meters. So you're going to fill in 18 here. And then they say, what is the total time between points A and B? So again, now I'm going to look over here for the time. So from 1.5 seconds to 3 seconds, a total of 1.5 seconds goes by. So I'm going to put 1.5 here. And then they want to know, what is the average speed in meters per second, which means that my 18 meters goes on top, and we're going to divide that by 1.5 seconds. And here you're going to plug it into your calculator, and we're just going to say 18 divided by 1.5 gives us a total of 12 meters per second. So we would just have to type in 12 here because they fill out the meters per second part. And then number 3. On number 3, they want to know which table could define a linear relationship. Now, again, guys, linear relationship means that as my y values rise, my x values rise at the same at a constant rate. It doesn't have to be the same number, it just has to be constant, meaning that the change in between each one is the same. So if I look, just for example, at this first one, the change between here is 1, 1, 1. So far that's good. But if I look here, I go up 2, 0, and then down 2. So that is not good. Okay. So as I go through this, I notice that each one of these have a constant change. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So what I want to do now is look at the y values. Okay. If I look at this one down here, it goes down by 6. It goes down by 2. It goes down by 1. That is no good. Over here on this one, it goes up by 3. It goes up by 5. Right away, I don't have to go any further, but if you want to see it, it goes up by 7. That is no good. So I look down here at this bottom one, goes down by 2, down by 2, down by 2. This is good. So this one down here is our answer. On this problem, it says the cost of a call under a certain long distance plan depends on the number of minutes a call lasts. The table gives a numerical representation of this relationship, including an initial cost of $2.90, meaning that's our starting point. No matter how long the call is going to last, there's going to be a $2.90 charge. Okay. Then if I look at the table, I notice that on top of the initial charge of $2.90, if I talk for 1 minute, my call now costs $3.10. So I find that there is a 20-cent difference there. And if I just check here between 1 and 2 minutes, there's also 20 cents. 20 cents between all of those. Each minute costs me 20 cents. So they want to know which relationship here or which description most accurately describes. So that means that some of these may describe it, but they want to know the one that has the most detail to it. So The cost of any call is the number of minutes times 20 cents. Well, that's true, but we also have to take in account the initial $2.90. So this one would not work. Then right below it, it says the cost of any call is $2.90. Yup. Plus, yup, the number of minutes times 20 cents. Yes. So we don't have to look any further. That's my next answer. On number 5, they just want to know what is the slope of the line. Guys, this is as basic as I get. So it's going to get, we're going to pick 2 points. I like to draw my points on there. And what is the slope? It goes up 1 over 1. So 1 over 1 is my slope. That gets simplified into just the whole number of 1. Number 6, what is the rate of change for the table? Guys, rate of change, that's a fancy schmancy way of saying what is the slope. Remember, for slope, we do the change in y over the change in x. So let's take a look here. From 225 to 450, again, you would just punch into your calculator 450 minus 225, and we see 225. You don't need to go any further, okay? Jump over here. From 1 to 2 candy bars, that's 1 candy bar. So 225 divided by 1 equals 225. So what is it? It is $2.25 per candy bar. Number 7, what is the y-intercept of this graph? Well, guys, if you remember correctly, to find the y-intercept, all we got to do is cover up that x and then solve. So 9y equals 18, divide both sides by 9, and we get that the y-intercept is 2. Number 8, this question, same exact idea, except this time they ask us for the x-intercept. To find the x-intercept, we cover up the y, and I get that 7x equals 28, divide both sides by 7, and we get that x equals 4. So 4 is going to be my answer here. On number 9, Marco wants to save his money to buy a new computer for school. He has $300 in his bank account. So guys, right away, that's our starting point. He has $300. Marco has a part-time job that pays $75 per week. How I write that is $75 per week. So times weeks. He plans to put all his money into his bank account each day, which the following functions accurately models. Guys, what that means is which equation shows this, okay? And it shows how much money Marco will have after X weeks. So they're telling us that that X right there stands for weeks. Well, I know that he's going to deposit $75 per week plus the $300 he initially starts with. So that matches this function right here. Number 10, the Math Club is selling t-shirts as a fundraiser. The function rule is C equals 7n plus 40 to represent their cost. My C represents my total cost. N represents the shirts. What could the numbers in the function represent? So let's talk about each number. If it is multiplying, the number multiplying to the shirt, so the 7 means that that is the cost per shirt. $7 equals cost of the shirt. So when I look at that, I see this one right here as an answer. And then let's talk about this 40. Okay, this 40 means like it's a one-time fee. It's a starting fee. So it has nothing to do with the shirts. So when I look here, well, we already said that $7 is the price for shirts. $40 is the minimum number, or 40 is the minimum? No. 40 has nothing to do with shirts, guys. 40 is going to be the setup fee. It's a one-time fee that they're going to charge every time you place an order. Okay, number 11. Which of the following is a line that has a slope of 5 and a y-intercept of 3? Okay, so guys, as a reminder, all of these are in slope-intercept form. Okay, where the number at the back by itself is going to be your y-intercept. So I look here and they say the y-intercept needs to be 3. Well, the only ones that have the y-intercept of 3 are these two. So I'm going to cross these two off over here. The next thing they say, it has to have a slope of 5. Well, a 5 needs to go in that spot. So that would be this problem, this answer right here. Number 12, what is the equation of a line that is perpendicular to y equals negative 1 over 2x plus 2 and passes through the point of 1, 3? So on this problem, guys, the very first thing we need to do is identify a perpendicular slope, okay? So here, if the slope of the original equation is negative 1 over 2, what that means is a perpendicular slope has to be the opposite sign, so it's now going to be positive, and then we flip the fraction. We take the reciprocal, so it's going to be positive 2 over 1. So what I need to do now, I can immediately cross off this answer and this answer. That leaves me with two choices. So what we have to do here, guys, is use the point slope formula because they give us a point that they want it to go through. As a reminder, point slope, y minus the y value equals my slope times x minus the x value. So let's plug this in. My y is permanent. We just found the slope of 2, and then that x value back there is going to be permanent. Let's plug it in. They say the x is 1, my y is 3. So now we have to solve this because both of those equations are in slope-intercept form. So I'm going to start by distributing that 2 to get y minus 3 equals 2x minus 2. Solve for y, add 3 to both sides, combine like terms, and we get that y equals 2x plus 1. Number 13. What is the x-intercept and the y-intercept of the following function? Guys, so this is just like we did before. The difference is if you look at our answer options, they want these written as points. So as a reminder, for my x-intercept, it's going to be the number that we find, comma 0. And for my y-intercept, it's going to be 0, comma the number that we find. Based off of just that alone, I can immediately cross off this problem because look at the x-intercept. They have it listed as a y. Okay, same thing down here. We can cross those off because they have the x-intercept listed as a y-intercept. So now we got to figure out which numbers go to what. So let's start by just figuring out what my x-intercept is. Okay, so remember for my x-intercept, we take out the y value. So I have 5x equals 15. If I solve, x equals 3. So now, before I go any further, because I know some of you guys are looking at that fraction going, oh my gosh, find that answer. Only this one up here satisfies that. We don't even have to look at the y-intercept. Okay, question 14. In point slope form, a student writes the equation of a line as y minus 5 equals 3 times x plus 1. What is the slope? So guys, this is just like what I did on the other page. This is in the format of y minus the y point equals the slope times x minus the x minus the x point. Okay, so here they just want to know what is the slope. Well, what letter represents slope? M. What number is in the same exact spot as the m? That would be the 3. So my slope is going to be 3. Number 15. Drag the correct value to what is the measure of the graph. So a couple things here, guys. First thing, easiest thing to identify is that my y-intercept is at the number 5. So I'm going to put the 5 at the y-intercept. Okay. The next thing I'm going to do is use the 2 points that they gave us here to identify the slope. And I see I'm going to go down 1, 2, 3, 4. So negative 4, and I'm going to go positive 2. -4 over +2. If we divide that, guys, we would get -2. So here my slope is going to be -2. Now the next thing they ask us is for the x-intercept. So I'm going to look at the x-axis, and I see that if this is the number 3 here, it falls between 2 and 3. So that would be my 2.5. So my my x-intercept is 2.5. Number 16. Based on the graph below, how would the line change if the slope was multiplied by 1? Okay, so this should be a pretty easy one if you remember our transformations. But in case you don't, I'll walk you through this. So right away, I see that my slope is up 1 over 1. So my m is a 1 over 1, or we could just say a +1. They want us to multiply it by -1. So if I times that by -1, I get a slope of -1. If I were to graph that, same exact thing, I would go down 1 over 1, down 1 over 1, and my line would look like this. So what is that transformation? Well, it didn't go up or down 1 unit. My slope doesn't increase. It's going from a +1 to a -1. That's going down. That's a decrease. The line would translate to the left 1 unit. Well, no, it stays exactly where it's at. If you look at that main point right at the center there, it doesn't move left or right at all. And then the last one is the line would be reflected about the y-axis. Yes, reflect means simply flip it. And that's what happened. It flipped over the y-axis. Number 17. Which graph shows a trend line that most accurately represents the data in the scatter plot? As a reminder, guys, trend lines run through the data, which all of these do, okay? But with this, it needs to go through the majority of the data. Here, it does go through 3 data points. Here, it goes through 2. Here, it goes through 2. Okay, so let's look at some of our other rules. There needs to be an equal number of points above and below the line. So here I see 2 points above, 1 point below. Here, there's 0 points above and 3, we'll call it 4 points below. That's not very equal. And over here, I see 2 points on, 2 points above, and 2 points below. So everything's pretty equal here. So I'm going to go with this last graph here. Number 18. The scatter plot shows the grades for 10 students on a recent test in relation to the time that the student spent studying. Based on the data, what is the best estimate for a test score made by a student who studied for 35 minutes? Because they're giving minutes, we're going to come down here. Well, this graph, it goes between 20 and 40, okay? But I don't, to give us 30. But I don't want 30, I want 35. So that's going to be in between the 30 and 40 mark, okay? So then if I took that straight over to the side, we have a couple options. It looks like it would fall right in the middle of 80 and 90, okay? Now this one's kind of difficult. I would probably say that it would be an 85. I think it's closer to 80 than it is to 100. So I'm going to go with 85 on this problem. Question 19. Which of the following best explains how graph A was modified to create graph B? Okay. Well, the first thing I notice, guys, is that they are flipped. This line is positive. This line is positive and this line is negative, which means one of the things that has to happen is that it is reflected, okay? Reflected, which means that we had to multiply it by a negative, Okay, so right away it says, the first one says multiply the slope and the y-intercept by 3. No, because we had to get a negative. This one says multiply the slope by a negative. Okay, so I'm going to keep that one. Right below it, it says multiply the slope and y-intercept by 2. Again, that's not negative. And then down here, it says multiply the slope by -3 and subtract 2 from the y-intercept. So again, we got the negative. So now let's look at what happens to the y-intercept. It starts at a +1 and ends up at 3. So it's going from 1 to 3. How? We're adding 2. 2 to the y-intercept. So which one of those lines says that we're going to add 2 to the y-intercept? This one right here. See, you didn't even have to worry about the whole multiplying by 3 part. It's just the negative we were looking at. And then lastly, number 20. Which of the following conclusions is most supported by the graph? Okay, so I look at this graph and I see we have chirps per minute and then the temperature outside. And what I'm seeing, guys, as there's more chirps, when I look at this graph, because it's going up, as I see more chirps, the temperature is also increasing. Okay, so when I look at this, it says there's no correlation. Well, no, we just said there's correlation. There's definitely correlation here, guys. Then it says the warmer the temperature, the less crickets chirp. No, as the temperature increases, there's more chirps. So it's not going to be that one. Then it says the cooler the temperature, the more chirping. Well, again, let's look at this. As the temperature decreases, they're saying crickets chirp more. Well, that's not correct, because if it's closer to 0, there's only 1 chirp. But if it's closer to 62, there's going to be closer to 12 chirps. So that's not it either. Lastly, the warmer the temperature, the more crickets chirp. Yes, the more crickets chirp, the warmer it is. Okay, so that's the quick go over. If you need to go back and look at some of those, you can, but otherwise you can go ahead and do your retake on this. Good luck.